We're going to look at disproportionation reactions. Now, these are quite interesting, and this is what Group 7 is particularly good at doing. So the first one is water purification. So you've got to know this equation, but the main thing is you understand why we call it a disproportionation reaction. So I take chlorine, and I react with water, and I make HCl, which is hydrochloric acid, and this guy, HClO, which is chloric 1 acid. Does anybody know what the one there relates to?
Oxygen's in it?
No, it doesn't.
Is it the oxidation state?
Yeah, that's right, yeah, it's the oxidation state of chlorine there. So let's go through this. What is the oxidation state of chlorine here?
0.
0. Elemental chlorine is 0. Of chloride here is going to be -1. And chlorine here is actually plus 1. Like so. So that's plus 1. So what's happened to the oxidation state of chlorine? It's gone from 0 to -1 and 0 to +1. So that is what we would call a disproportionation reaction, when one species both goes up in oxidation state and down. So I start with 2 chlorine atoms here. One of them goes down in oxidation state, and the other one goes up in oxidation state. And that's a disproportionation reaction. Why is this a useful reaction? Well, as you know, we put chlorine into water. We do this, we make chloric 1 acid, which kills bacteria in swimming pool for us, which is good. However, if we have bright sunlight, a different reaction occurs. This isn't a disproportionation reaction. How can you tell straight away this can't be a disproportionation reaction for chlorine?
There's only one molecule of one species.
There's only one species over here of chlorine, so this isn't a disproportionation reaction. It starts at 0 here, and it goes to -1 there. So chlorine has been reduced, and oxygen has therefore been oxidized, because he's -2 there and 0 there. So that happens in sunlight. So you think, well, why is that a problem? Well, it means if in bright sunlight I'm not going to form this, and if I don't form that, it means that the bacteria don't die. So I have to do something else. So if I've got a swimming pool in bright sunshine, you have to use, you can't just dissolve chlorine, you have to use this species, sodium chlorate 1. You react it with water, and you form chloric 1 acid this way, like so. The issue with this is this arrow here. This tells me it's it's reversible, it's in equilibrium. So if my swimming pool becomes quite alkaline for any reason, so I've got lots of hydroxyl ions, what's going to happen to this equilibrium? Shift to the left-hand side. What's going to happen to the concentration of this?
Drop.
It will go down, which means my bacteria can survive. So how can I do that? I can make my swimming pool slightly acidic, which means it can, obviously you don't want it to be strongly acidic, because otherwise you have all sorts of other problems kicking off there. So this is the other reaction you need to know. So this is a disproportionation reaction. Let's have a look. What's my oxidation number of chlorine there? 0 there. Let's go there. Chloride is going to be -1. And again, this is the chlorate ion. If you want to work this out, you'd be able to. Sodium is going to be +1. Oxygen is always -2, so what must chlorine be? So it's got to be +1 to count that out. So is it a disproportionation reaction? Yes, it is, because chlorine has gone from 0 to -1 and from 0 to +1. What is bleach? This boy is bleach. So that's how you get bleach. Like so. And again, you need to know that reaction. All the other halogens react in a similar way to those. The only other thing